Begin 1977 minutes. I want to presentation of my title is electronic stethoscopes equipped with IoT plus remote detect disease symptoms. Struck struck auscul- auscultation commonly used in initial patient exam with a stethoscope has limitation to subjective diagnosis. This study aims to develop an IoT system for electronic stethoscope, providing DTM output and incorporating analog filter to overcome noise interference. The research, the research facilitates easier heart rate analysis for medical users, allowing remote monitoring through the IoT system. The study involved tracking voltage change on condenser mic, which feed into an analog signal conditioning circuit and then into a program microcontroller. Next, introduction. Auscultation, a common method in initial patient exam, using involve using a stethoscope, a simple acoustic medical device, to diagnose sound in the human body. Medical personnel often use aqueous stethoscopes to assess heart sound, providing information on heart rate, rhythm, and pulse effectiveness. Despite being preferred over conventional stethoscope, the noise is still too large during a preamplifier and filters such as EER, Chebyshev waffle to ATC to eliminate unwanted frequency. Previous study did not find remote monitoring for heart rate sound signal analysis through the Internet of Things IoT using the Android system. This research the research aimed to create and this research aimed to create an IoT system for electronic stethoscope with PPM output and analog filter to eliminate noise interference, facilitating research analysis and diagnosis of heart impact by doctor with wisdom disease symptom detection capabilities. Okay, next materials and methods. The experimental setup. Number one, material and tool. The material used in the study was a SPID32 microcontroller, which was used as the system control and for data transmission via the Internet of Things, which was further displayed on an Android using the link system. But to experiment, in this experimental study, a condenser mic was placed on the patient's chest to detect pressure change. After that, the signal was filtering use an analog signal conditioning circuit. Furthermore, testing was carried out on 5 respondents, and each respondent was shared 6 times. In this case, the analog circuit consists of a preamplifier circuit and a bandpass filter circuit that was a combination of the combination H high pass filter 20 decibel and low pass filter 20 decibel circuit. Furthermore, the PPF output was employed as an additional circuit input to increase the reference of the heard sound signal so that there was no negative signal entering the main system circuits since the main system cannot detect the negative. Next, it this diagram block. In this diagram block, you can look the picture. Next, this diagram blocks. The condenser mix was placed on the patient chest to detect the pressure change in this case. As the pressure changed, the voltage output value on the condenser mic also changed. The output from the condenser mic was further entered and processed in the analog signal conditioning circuit. The signal output from the analog signal conditioning, the signal output from the analog conditioning went into the pre-programmed microcontroller. This microcontroller was used to process the signal on the dBm bit or bit per minute. In this case, when a cardiac arrest is detected for more than 10 seconds, the microcontroller will send data to the Android via the Wi-Fi network. In addition, when respiration occurs, the respiratory indicator will also like sound into an electrical signal. In the preamp circuit, there was signal gain process from the condenser mic, but there was still interface. Eh, there was still interference or noise as well. Therefore, a series of bandpass filters were made to reduce the noise from a combination of the high pass filter 20 decibel and low pass filter 20 decibel circuit before entering the mini circuit. Okay, next, this flow chart. In this flow chart, condenser mic was first entered the capacitor that functions as a DC coupling and then was corroborated using a non-inverting amplifier circuit. Next, it was filtered to remove the noise. The output of the filter circuit then entered a multitron to set the reference value of the signal. After the stethoscope signal has been raised by the header circuit, the signal entered the SP32 microcontroller, which later was processed and displayed on the 1662 character LCD. Furthermore, the data were sent to the ByLink Android application using a Wi-Fi network to make it easier to retrieve the data. Next, result. Measurement result in respondent in the measurement on of the study. Three comparison of DVM reading measurement were carried out, including reading on the module that had been readings on the oximeter and readings sent through the Billing application display on Android. Two statistical test result using t-test in order to find out whether there were significant difference in the measurement of each display, namely the LCD display oximeter and Billing system reading display displayed on an Android cell phone. A t-test statistic test was carried out using the p-value of more than 0.05 based on the result of the T ANOVA obtained from the measurement of each respondent with three output parameters, namely those displayed on the LCD display oximeter and Billing display on Android. Mean value obtained was 85 ppm to 59, and the p-value obtained was 0.9986, indicating that the p-value. The next, the conclusion. When compared, the artificial neural showed the highest classification operation of 65.43% among the methods using SVM, AAN, and ENN. It was found that the similarity between the waveform disjoint subsignal and original signal reflect time frequency characteristic of the signal. The statistics were chosen as the elements of the Peter vector classifying the normal and abnormal Langson because the Gaussian kernel function used in the study is related to the amplitude of the subsignal and normalization step condition before obtaining the signal similarities. Step may lead to an accumulation of error. Therefore, a new statistic which measures the signal similarity so the proposed for the more multiple signal in regression study should be conducted in medical sound signal research. Although there are several waveform families including the pitches in the study, the choice of function was chosen because it achieved good performance under practical situation. Thank you. Assalamualaikum.